Okay. Whoa, that was pretty loud here. Let me figure this out. Good morning, everybody. It is an honor to be here and share the stage with so many talented speakers and to have been, privileged enough to travel from the States to come here and talk. This talk might be a little bit different than what we've been talking about the rest of the conference, but I'm going to be talking about type-safe React with OCaml, a practical guide. But who am I? My name is DILLON Mulroy. I am a software engineer at Vercel. And this was not intentional, but as our friend David called out, I happen to be wearing black. It's not company mandated. I do it because it makes my tattoos look cool. So, all right. Where can you find me? I do a lot of streaming on Twitch, a lot of functional programming. I do things like OCaml, Gleam, Effect.ts, which we already heard about. I do that every Monday through Friday, 7 a.m., 10 a.m. Eastern time, so if that's your thing, feel free to tune in. I do a lot of yapping and ship posting on Twitter. All my open source work is at my GitHub, and then you can find everything about me at Dillon is Online. Now, this code is going to have quite a bit of code samples, and it's going to be in a programming language I would imagine most of you are unfamiliar with. So if you would rather follow along on your own device, feel free to check this out. In fact, I actually forgot to push my slides, so don't do that until afterwards. So this talk was going to be a deep dive on OCaml and React. We were going to cover best practices, design patterns, testing, DX and tooling, and really getting in the weeds of how to bind to your favorite TS/JS libraries, whether that's Xstate or Redux, RTK, or LeftPad. That being said, 30 minutes is a short amount of time, and earlier this week I had a change of heart, and I realized that I wasn't going to be able to convey in that amount of time the things I wanted to. So instead of covering a deep dive on this, we're going to focus on the why. So really my goal today is to spark your curiosity and excitement about OCaml, functional programming more broadly, and to demonstrate how these ideas and this language can improve the type safety of not only our React applications, but our code in general. So before we dive into why, we should probably kind of talk about the what a little bit more, right? OCaml. And honestly, this is kind of what it feels like, getting ready to come to like a conference geared towards TypeScript, JavaScript, and React. Normally it's like a wolf in sheep clothing, but honestly, a camel. So what is OCaml? OCaml is actually an acronym, and it stands for Objective, Categorical, Abstract, Machine Language. And if you're anything like me, I know what those words all mean individually, but together, no idea. I do not have a background in type theory or category theory or even a strong background in mathematics. That being said, the last time I did think about what that meant, I was shitposting on Twitter. It's only OCaml if it comes from the objective region of France. Otherwise, it's just sparkling categorical abstract machine language. So what really is OCaml? The OCaml.org website describes it as an industrial strength functional programming language with an emphasis on expressiveness and safety. But how would I describe OCaml? Well, I would describe it as a statically typed language with amazing type inference, and we're going to dive into how this works later and how it differs from TypeScript. It's immutable by default with opt-in mutability, which is not all that common of a thing in other functional programming languages. It's blazingly fast. Just writing simple idiomatic OCaml code, you can get like 50% the speed of C, talking about performance like Go. It's awesome. And in my opinion, it's really a pragmatic application of functional programming for the real world. I'm sorry if there's any Haskell devs in here, but I don't want to spend all my time writing white papers. And quite honestly, the community is top tier. I came from the first industrial use case conference in Berlin this week, where a bunch of the OCaml community got together and talked about how we're actually using OCaml. And the most important thing is it's fun and a joy to write. So what is Melange? Melange forgot I had it slide, but if anyone is familiar with Dune, the book or movie, it is the drug or the spice that comes from the desert that they're all kind of fighting over. Funny enough, OCaml's build tool is called Dune, so it's got that nice little tie in there. So really, what is Melange? Melange is a compiler for OCaml that emits performant, modern, and readable JavaScript. And let's dive into like why OCaml now. Now that we have an idea of we have this compiler that can compile OCaml code down to JavaScript and kind of like the foundations of like what OCaml is at a high level. I got the opportunity 2 years ago to work full-time in OCaml for almost 2 years. And up until that point, I have been writing TypeScript and JavaScript pretty much for 11 years professionally. And I've been writing JavaScript since I was 13, so 18 years of JavaScript at this point. It's my bread and butter. I had never written a functional programming language full-time until I had this opportunity, and this tweet kind of sums it up. I can't think of a decision that has been more positively impactful on my skills as a developer than properly learning OCaml and functional programming. It has made me a better engineer even when working in languages like TypeScript. So really, why OCaml in my own words? Well, it has a sound type system. It treats errors as values. It has some types and pattern matching, great DX, and I can write it once, and I can use it anywhere. I can write it, compile it with Melange for the browser. I can run it natively for CLI apps, or sending it to Lambda, or serverless environments, edge environments. I can use it everywhere. I don't have to have this mental shift of, oh, I write TypeScript and React on the front end, and then I have to go write Rust or Go on the back end. It's just there, and it's performant for pretty much every use case. So let's look at some code, see what this kind of looks like in practice. So is everyone or anyone familiar with Vercel's AI SDK? Essentially a tool to kind of generically work with all the AI models out there. This is what it looks like to use, right? We're going to import some stuff. We're going to call generate text. We're going to pick our model and provider. We're going to give it some prompts, and then we're going to get that back. And we can do this over and over again. You can stream it. So what would this look like in OCaml? Well, this is what it looks like. And this might seem a little foreign at first, but hopefully you can pick out the pieces that we just looked at, right? We have let main article. Main is a function, article being the only argument. And we just go down through, and it should look pretty familiar to what we just saw. And if we dive a little bit deeper and looked at what the, where that GPT-4o on the model line comes from, it's going to come from a module like this, where we have this type T. We're just saying, hey, this is the, if you can imagine this being a single file or an ECMAScript module, right? Type T is kind of the way we express in OCaml, like this is the main type that we're going to operate over in this file. So we have a sum type here with the different models. We have a way to convert those sum types to strings. And then we have this weird, like crazy looking external OpenAI. This is just some syntax that we call FFI. So it's our foreign function interface. This is how we bind to our JavaScript. Again, not super important. You can always come back to this and look at it, use it as a place to get started. Again, we have the same thing for Claude or Anthropic. And then putting it all together, the AI module that we called, we define a type that can be another sum type. It's OpenAI of the module we looked at, same with Anthropic. We have some options which we're going to pass in, and then our result type, it's also typed, and it's just the text string. And again, we're going to bind to the AI npm package for the generate text, and it's going to be a function that takes our options type and returns a promise of our generate text result. And if you were to look at the code that was compiled for our OCaml, this looks super similar to what we wrote in the first place. I am always surprised by the output of the Melange compiler. Again, another example of the code that is generated. Pretty honestly straightforward and not all that dissimilar to what we would normally write. So Melange also helps us support bindings to React. Specifically, Melange has actively maintained bindings to React, including all of our favorite features and APIs. In addition, there's an implementation of React's server APIs in native OCaml, and we'll get into why that's exciting and how we can use that a bit later. So let's look at an example of how we might use React in OCaml. So here we just have a typical counter component, right? We have some action that we're going to dispatch, right? Counter props, some initial state we're going to set to 0. We have our user reducer. Nothing super exciting here, your typical counter. And now this is the same exact code in OCaml. We have JSX built in, and we have far less types, and it just works. And it's the beauty of some types and pattern matching here. We get to eliminate so much boilerplate and get a more sound code base. But did you notice anything about the OCaml code? Perhaps the absence of something? There are no type annotations. Yet we have 100% accurate and sound inference. And this is not like TypeScript's inference. TypeScript has inference in the way where when we're working with generic parameters or return types, it's going to more closely infer the shape of our data rather than inferring some nominal or named type that we've declared elsewhere. But how does this work? Really, the magic is Hindley-Milner, which is the type checking algorithm that languages like OCaml, Haskell, Gleam all use under the covers. So to build a basic intuition, let's look at this simple two functions here. We have let foo, s, that gets passed to string.length. And actually, to make this a little bit easier to read, I've put parentheses there. We don't really use parentheses in OCaml, but this is what it would look like. But can anybody tell me what the type of s is? Anyone? String. Yes, string. You guys are disqualified. How about the type of X? Also a string. What about the type of Y? Yes. So how does this work under the covers? So let's start with foo. String.length is a typed function that will only ever accept a string. It can't take anything else. No matter what you do, the compiler will not let you, and it returns an integer always. So we know that s must always be a string, right? X gets passed into foo. We've already determined that foo only ever takes a string and returns an int. Therefore, x must be a string. It returns an int, and we can only ever operate on ints and ints together. So y must be an integer. So Hindley-Milner basically works under the covers by looking at how you use your variables and your expressions and kind of generalizes to the types it knows about and based on usage. So let's say you had like a user object and you pass it into a function, you're on like isAdmin or username. It knows about that type that we've defined elsewhere, and it may be the only record that has those fields, so it knows it can only be that user object. Okay, time for some hot takes. So my hot take is that JavaScript has the lowest bar of entry to building and being productive, which is an amazing thing. But one of the highest bars of any language and stack to building high quality, stable, and reliable software, and very few devs have the expertise to pull off the ladder. Now this tweet, I'm really thinking about Node in this context, but I think it applies to the language in general. I think TypeScript and JavaScript as like a fundamental language makes it too easy to put on blinders and focus on the happy path, and that leads to brittle software. So I also want to talk about TypeScript, kind of in the same vein, right? TypeScript is statically typed. It has excellent tooling. We probably have some of the best tooling across any language or stack. It enables a great dev experience. Like we have a really good LSP. Overall, TypeScript is a vast improvement over JavaScript. I think we can all agree on that. That being said, TypeScript works against you instead of for you. Like until you've built the really hard muscle memory of knowing how to work with map types and getting into these nested ternaries and very highly dynamic types, it's really, really hard to move quickly in TypeScript. TypeScript is also burdened by JavaScript's warts and dynamism, right? We have to capture that dynamic typing in our type system, which is very difficult. TypeScript has too many escape hatches. It can create a false sense of safety, and ultimately, TypeScript is unsound. And don't just take my word for it. Anders Hallsberg, hopefully I got his name right, he's the creator and lead architect of TypeScript. He gave a keynote at the International Conference of Functional Programming last year talking about TypeScript's type system, where he said, I mean clearly, this type system is not sound, and it was never designed to be sound. And most gradual type systems are not sound. But what does unsound really mean, and why should we care? A type system is considered sound if it guarantees that a program will not cause certain types of runtime errors, assuming that the program successfully type checks. So what makes TypeScript unsound? Well, we have some usual culprits. Any, type assertions via the as keyword, non-null assertions, us telling the compiler we know better, typecasts via type guards and predicates or function overloads. Really, if we're using these features, we are inherently accepting a degree of risk that may not always be true, or may not be true in the first place. So, surely then, if we avoid those features of TypeScript, we'll have sound and type-safe code. Unfortunately, not. And let's look at an example. So let's say we just have some basic app, we have an account, it has a username string on it, maybe an isAdmin boolean. Somewhere else in our application we have a way to validate that username, right? It just takes in some object that has a username, checks that the length is good, throws an error if it doesn't. You might imagine we have the always lovely utils folder with a billion files in it. We have a print record, takes in pretty much any type and just like helps us print out, see what we're working with, right? And then you can think of this block of code as kind of like the main part of our application, right? We have an account, username daemon MULROY, is admin true. We pass that in to validate username and print record, right? Pretty straightforward. It's code we've all written. You could see this show up in pretty much any code base you've ever worked in. That being said, this successfully type checks and compiles on the strictest settings of the TypeScript compiler, but there's still a runtime type error and it will error. Can anyone pick it out? You're correct. Yes. The problem lies right here. So let's break this down. So we have isAdmin on our account, but print record takes a record of string, but really we're passing like a record of string or boolean. And when we go to call trim on that, that's not going to work, and we're going to get an error in prod. That being said, despite all this, I love TypeScript. I've built my career off TypeScript. I write TypeScript every single day. It has introduced a whole generation of developers to the merits and benefits of static typing and type safety. The TypeScript team is one of the most impressive teams genuinely in open source. It has improved the quality of our applications, code, and experiences for our users. And if that doesn't convince you, I maintain 2 NeoVim plugins. I use NeoVim, by the way. TSC NVim and TS Air Translator NVim. The first is used to run the TypeScript compiler asynchronously and manage project-wide diagnostics. The latter is a direct port of Matt Pocock's VS Code extension of the same name and helps make the lovely TypeScript errors a little bit more human-friendly and readable. Okay, let's get back to OCaml. And I want to dive into OCaml and React, but like let's start from first principles here. So let's look at this basic component. We have module, say hello equals struct, some weird let thing with some weird characters, a word make. Let's dive into this. So modules, like I described earlier, every file, much like JavaScript, in OCaml is a module. But OCaml has this unique ability that you can also nest modules. So it's a pretty common way to encapsulate code and types inside a OCaml code base. So you'll commonly see components scoped inside of their own modules. Next, we have this weird let at react.component inside some brackets and then the word make. Make is a common convention in the OCaml world. You could think of it as like new or kind of like a constructor. It's just a function in this case. We could call it render, but convention is make. But what the bracket's doing here is, if you're familiar with Babel or Rust macros or Elixir's macro system, at compilation time, the compiler is going to see this and it's going to say, hey, I need to generate some extra code here. It was the author's intent that this needs to be a React component. So it's going to generate a bunch of extra React bindings and stuff under the covers for us at compiler time. The next bit here is a named argument. So this is our props, right? Make, tilde, name, and then we use that as our single prop for this argument. And then this looks like our normal JSX. We have this weird react.string thing in the middle, but it should seem pretty familiar. The reason we need react.string is because of OCaml's type system. JSX is React elements under the covers. A string is not a React element, so we have to convert it to a React element using the React string function. So next we can see our app, right? We can just continue writing React like we normally would. We render our say hello component with passing React Alicante as our name. And when we want to, build up the full application, we can just query the root DOM, create our root, pass that the client render, make sure we're in strict mode, and go on our way. And this is what Melange is going to output for us, right? This is exactly what we're compiling our JSX to anyways. So we can see here we get the JSX runtime. We see we're passing in a HTML component or a prop, or excuse me, a component name, giving it children, and just going forward and forward. This all looks exactly like what we're familiar with. So I mentioned earlier that we also have the ability to render to native. We have a full implementation of React in native OCaml. And this is what a React element is actually typed as in native OCaml, right? We have all the things here as a sum type. We can pattern match on these things. Very lovely. We also have all of your favorite server APIs. We have render to string, render to static markup, render to stream. And if you wanted to use these on the servers, Dream is just like Express or Hono. Don't mind too much there. We'll say on our index route, we're going to get some request, and we're going to render HTML. We're going to use React DOM server, render to static markup, pass in our document with the bundle, app, document, and it's just going to spit this out, just like we would normally SSR React in any other context. So why is this exciting, and why should we care? Because we get native performance, right? I mentioned earlier that OCaml running, it compiles down to native binaries. It's very, very, very fast. And you have to take benchmarks with a grain of salt, right, always. But objectively, rendering React on the server with OCaml is the fastest way to render React. And the React, or the Melange team at Ahrefs is continuously working on making this better. But wait, there's more. We have universal components, right? This was the dream of React going way back to like 2014, right? Like we wanted to share components and types on the server, talk about isomorphic types back in the day, right? That's the dream and the pitch of React server components. So we get that. We can share our components in native OCaml where we have the crazy speeds that gives us. And we can also use that same code and those same components in the browser to compile to JavaScript with Melange. We also get nice things because we have access to a macro system. We have access to OCaml's type system. We can declare something something should be browser only, or maybe we want to check what platform we're on, right? We can do all of that with built-in macros. So some things to look forward to in the OCaml and React world. The Melange team is working on React server components. They're working on Utopia, which would be the easiest way to think about it would probably be comparing it to Next or Remix, but more ergonomic for the OCaml language, and then constantly iterating on DX and stability. So if you're wondering how to get started, the easiest way, in my opinion, is using Create Melange App, which is a tool that will help scaffold this out. You can simply do that by running npx create melange app at latest. You can also find really good documentation at melange.re. There is also a book, React for Melange developers, for free online, where you can walk through basically a full course on how to build a real application using Melange, React, OCaml. And again, ultimately, You know, I mentioned this slide earlier in this tweet. OCaml was without a doubt the most impactful thing I've ever learned in my career. You know, 2 years ago, before I had the opportunity to work in it full time, I had spent my entire career working in just TypeScript. My impression and understanding of what a type system was it's gonna look and feel like Java, C#, Go, TypeScript. It's gonna be verbose. It's gonna, you know, I'm gonna have to spend time fighting it and getting my stuff completely correct before I can move on with my code. And you just kind of get this light bulb moment that's so hard to put into words when you use a type system like OCaml, where it actually works for you and it helps guide you and it doesn't get in your way. So I think ultimately my takeaway for y'all is be curious, step outside your comfort zone, learn something new, hopefully OCaml and Melange, and deeply care about our craft. Thank you.